Have you ever wondered why SpaceX keeps launching Starship even after one explosion after another? To many people, every failed flight looks like a disaster. But inside SpaceX, every explosion is treated as valuable data. Every test reveals weaknesses, uncovers hidden problems, and helps engineers build a better spacecraft. That philosophy has transformed Starship from an ambitious idea into the most powerful rocket ever built. And now, all eyes are turning toward a vehicle that could become one of the most important starships yet, Ship 13. Unlike earlier prototypes, Ship 13 isn't just another spacecraft rolling out of the factory. It's the result of years of testing, redesigns, hardware upgrades, software improvements, and countless engineering lessons learned from previous launches. Today, we're going to explore what makes Ship 13 different, why SpaceX engineers are so excited about it, and how this vehicle could bring humanity one step closer to returning to the moon and eventually reaching Mars. But before we talk about Ship 13 itself, we need to understand why Starship exists in the first place. For decades, rockets followed the same basic rule. They were designed to fly once. After delivering their payload into space, most rockets burned up in Earth's atmosphere or crashed into the ocean forever. Imagine buying a brand new Boeing 747, flying it from New York to London, and then throwing the airplane into the sea after landing. It sounds ridiculous. Yet that was exactly how spaceflight worked for more than half a century. Every launch cost hundreds of millions of dollars because every launch required building an entirely new rocket. That changed when SpaceX introduced reusable boosters with the Falcon 9. Many experts believed landing an orbital booster vertically was impossible. Today, it has become almost routine. The first stage lands itself on a drone ship or back at the launch site, gets inspected, refurbished, and flies again. This single innovation dramatically reduced the cost of reaching orbit. But Elon Musk had a much bigger goal. Instead of reusing only the first stage, why not reuse everything? Both stages, every engine, every tank, every component. That idea became Starship. Starship isn't simply another rocket. It's designed as a complete transportation system. The lower stage, known as Super Heavy, provides the enormous thrust needed to leave Earth. The upper stage, simply called Starship, carries cargo, satellites, astronauts, or eventually entire crews heading toward Mars. Together, the system stands roughly 123 meters tall. That's taller than the Statue of Liberty. It's taller than most office buildings. And with 33 Raptor engines firing simultaneously, Super Heavy generates more thrust than any rocket ever constructed. The numbers are staggering. Millions of kilograms of thrust. Thousands of tons of propellant. Temperatures reaching thousands of degrees. Cryogenic methane and liquid oxygen stored just above absolute zero. Everything about Starship pushes engineering to its limits. But building the world's biggest rocket isn't enough. It also has to survive. It has to launch. It has to separate. It has to reach orbit. It has to survive re-entry. It has to land. And eventually, it has to do all of those things again and again. That's where things become incredibly difficult. Every test flight is essentially a giant engineering experiment. Thousands of sensors collect millions of data points every second. Pressure, temperature, engine vibration, fuel flow, hydraulic systems, electrical systems, computer performance, guidance algorithms. Every tiny detail matters. Sometimes the rocket explodes. Sometimes an engine shuts down unexpectedly. Sometimes heat damages critical components. Sometimes software behaves differently than engineers predicted. To the public, these look like failures. To SpaceX, there are opportunities to improve the next vehicle. That's why every Starship has been slightly different. Each prototype introduced new hardware, new plumbing, new software, new engines, new heat shield tiles, new structural reinforcements. Nothing stayed the same for long, and that rapid evolution has brought us to Ship 13. At first glance, it may look almost identical to earlier Starships, but underneath its stainless steel skin lies a vehicle built using lessons from every previous flight. Many engineers believe Ship 13 represents one of the biggest evolutionary steps in the entire Starship program. So, what exactly changed? And could Ship 13 finally deliver the fully successful mission SpaceX has been working toward for years? To answer that question, we first need to look back at the dramatic journey that brought Starship to this point. Before Ship 13 ever reached the launch pad, SpaceX had already learned more about giant reusable rockets than any company in history. Those lessons didn't come from perfect missions. They came from failures. Some of them were spectacular. Entire vehicles exploded during landing. Others failed during ascent. Some never even left the test stand. But each failure answered questions that engineers simply couldn't solve on a computer. That's because a rocket this large behaves in ways that simulations alone can't fully predict. Every vibration, every pressure wave, every temperature change creates new engineering challenges. And the only way to discover them is by flying. Back in 2019, the first stainless steel Starship prototypes looked almost unbelievable. Many people laughed at them. Compared to traditional rockets built from lightweight carbon composites or aluminum alloys, these shiny steel vehicles looked unfinished. Some even compared them to water towers. But SpaceX had a reason for choosing stainless steel. It was cheaper. It was stronger at extremely low temperatures. It tolerated higher temperatures during atmospheric re-entry. And perhaps most importantly, it allowed SpaceX to build prototypes incredibly fast. Instead of spending years constructing a single vehicle, engineers could build, test, destroy, redesign, and build another one within months. That speed became one of the company's greatest advantages. The early Starship flights were all about one thing: learning how to land. Several prototypes successfully climbed to around 10 kilometers before shutting down their engines and falling back toward Earth. Moments before impact, they performed the now famous belly flop. Instead of falling nose first, Starship rotated into a horizontal position, using its large flaps to control its descent through the atmosphere. The maneuver looked almost impossible. No rocket of this size had ever attempted anything similar. At the last possible moment, the engines reignited. The vehicle flipped back to a vertical position. Sometimes it landed. Sometimes it exploded seconds later. But every attempt improved the system. Little by little, SpaceX transformed an impossible-looking maneuver into a repeatable engineering process. Then came orbital testing. Everything became dramatically more complicated. Instead of one or two engines, the Super Heavy booster now had 33 Raptors firing at once. Coordinating 33 engines isn't simply 33 times harder. It's exponentially more difficult. One engine shutting down changes the forces acting on the vehicle. Fuel pressure shifts. Computer algorithms adjust thrust in milliseconds. Temperatures change. Vibrations spread through the entire rocket. Every launch became one of the most complicated engineering experiments ever attempted. Despite several impressive achievements, SpaceX still encountered major challenges. Heat shield tiles occasionally detached during flight. Some engines shut down unexpectedly. The ships sometimes experienced excessive heating during re-entry. On other flights, The planned engine relight in space didn't occur exactly as intended. Each issue delayed the next major milestone, but also gave engineers valuable data. Instead of redesigning the entire vehicle from scratch, SpaceX followed its usual philosophy. Fix the problem. Improve the hardware. Fly again. Repeat. That rapid iteration has become one of the defining characteristics of the Starship program. By the time engineers began preparing for Flight 13, the program had entered a new phase. This wasn't simply another prototype. It was the second flight of the upgraded version 3 Starship architecture, pairing Ship 40 with Booster 20. Both vehicles incorporate numerous improvements over earlier designs and have gone through extensive cryogenic and engine testing before launch preparations. One of the biggest goals of Flight 13 is straightforward. Prove that the latest hardware is reliable. SpaceX isn't chasing flashy headlines. It's chasing consistency. A reusable launch system only becomes practical if it performs successfully over and over again. Every successful launch reduces uncertainty. Every successful landing builds confidence. And every successful test brings Mars a little closer. Another reason Flight 13 is attracting so much attention is what comes after it. SpaceX has made it clear that orbital refueling is one of the program's highest priorities. Without transferring propellant between starships in orbit, long-duration missions to the Moon and Mars become extremely difficult. Flight 13 is expected to help pave the way toward those future demonstrations. Think about that for a moment. A Starship launches from Earth. Another Starship launches days later. The two spacecraft meet hundreds of kilometers above our planet. Then, they transfer hundreds of tons of supercold liquid methane and liquid oxygen between two vehicles traveling at nearly 28,000 kilometers per hour. Nobody has ever demonstrated a system like that at the scale SpaceX is planning. If it works, everything changes. Mars suddenly becomes much more realistic. Lunar cargo missions become easier. Massive space stations become possible. Even telescopes larger than anything we've ever launched could one day be assembled using Starship. That's why Flight 13 matters so much. It's not just another launch. It's another step toward building a transportation system that could fundamentally change humanity's relationship with space. And surprisingly, the biggest challenge isn't building a rocket powerful enough to reach orbit. It's making sure that rocket can survive the trip back home. In the next part, we'll dive deep into the engineering changes inside Ship 40 and Booster 20, explain how version 3 differs from earlier Starships, and explore why many engineers believe these upgrades could become the foundation for the first truly operational Starship system. By the summer of 2026, the Starship program had entered a completely new era. The first version 3 vehicle had already flown, giving SpaceX an enormous amount of real-world data. Now, all attention shifted toward Flight 13. Unlike the early days of Starship, this mission isn't about proving that a giant stainless steel rocket can leave the ground. SpaceX has already demonstrated that. The focus has changed. Now, the company wants to prove something much more important. Reliability, consistency, repeatability. Those 3 words define the future Starship. A rocket that reaches orbit once is impressive. A rocket that can do it every week changes the world. That's exactly what Flight 13 is designed to move toward. Before any launch can happen, the vehicle has to survive weeks of testing. One of the most important milestones is the static fire campaign. During these tests, the rocket remains firmly attached to the launch stand while its engines ignite at full power. To an outside observer, it may look like nothing more than a spectacular fire show. For SpaceX engineers, however, it's one of the most valuable moments before launch. Every sensor inside the vehicle comes alive. fuel pressure, engine temperatures, vibration, hydraulic systems, electrical systems, computer timing, valve performance. All of it is monitored in real time. If even one critical value falls outside acceptable limits, engineers investigate before the rocket ever leaves the ground. For Flight 13, Ship 40 completed a full-duration static fire with all 6 Raptor engines. The firing lasted approximately 60 seconds, making it one of the most comprehensive engine tests ever performed on a Starship upper stage. This wasn't just about seeing flames. It was about confirming that 6 engines, multiple fuel systems, avionics, and flight software could all operate together exactly as planned before launch. Another major improvement is hidden inside the engines themselves. The latest Starship vehicles use the newest generation of Raptor 3 engines. From the outside, they look similar. Inside, they're dramatically different. SpaceX engineers simplified plumbing, reduced the number of external components, improved thermal management, increased reliability, and made maintenance easier between flights. That last point is especially important. If Starship is ever going to launch hundreds or even thousands of times every year, servicing each vehicle for months after every flight simply isn't practical. Everything must become faster, simpler, and more reliable. Version 3 Starships also carry more propellant than previous generations. That means more performance, more payload, greater margins during demanding flight maneuvers, and eventually, longer missions beyond Earth orbit. SpaceX is designing these vehicles not just for Earth orbit, but for destinations hundreds of millions of kilometers away. Mars isn't just part of the marketing. It's influencing engineering decisions today. Every kilogram saved, every improvement in engine efficiency, every software optimization, all of it matters once you leave Earth's gravity behind. Perhaps the biggest long-term challenge isn't launching Starship. It's refueling it. Imagine driving across an entire continent without stopping for fuel. Impossible. The same applies in space. A fully loaded Starship heading toward Mars cannot leave Earth with all the propellant it needs. The rocket would simply be too heavy. Instead, SpaceX plans something that has never been done on this scale before. Launch multiple Starships. Fill one with propellant. Launch another carrying astronauts or cargo. Dock them together in orbit. Transfer hundreds of tons of cryogenic methane and liquid oxygen. Only then, begin the journey toward the Moon or Mars. It's an extraordinarily ambitious concept, but it's central to the company's long-term roadmap. And this explains why every single Starship test matters. Flight 13 isn't expected to fly to Mars. It isn't expected to land on the Moon. Instead, it's another building block. Every successful engine burn, every successful stage separation, every successful re-entry, every successful landing attempt moves SpaceX one step closer to a transportation system capable of supporting human exploration far beyond Earth. The ultimate goal has never changed. Make life multi-planetary. And while that phrase has become famous, achieving it depends on solving hundreds of engineering problems, one flight at a time. As engineers prepare Flight 13, work has already begun on future vehicles. Factories continue producing additional version 3 Starships. New boosters are already in different stages of assembly. Testing never stops. The philosophy is simple. Don't wait years for the perfect rocket. Build, test, learn, improve, fly again. That rapid development cycle has allowed SpaceX to progress faster than almost any previous launch program. The pace is relentless. And if Flight 13 succeeds, the company will move one step closer to an era where Starship launches become as routine as Falcon 9 missions are today. But perhaps the most difficult challenge still lies ahead: surviving the fiery return through Earth's atmosphere. A spacecraft traveling at orbital velocity experiences temperatures hotter than molten lava. Its heat shield, structure, engines, and guidance systems all have to work perfectly. In the final part of this documentary, we'll explore how SpaceX plans to solve that challenge, and why the success of Flight 13 could influence not only future Starship missions, but NASA's plans for returning humans to the moon as well. If launching Starship is difficult, bringing it back to Earth may be even harder. During re-entry, the spacecraft slams into Earth's atmosphere at incredible speed. Air can no longer move out of the way fast enough, so it compresses in front of the vehicle, creating temperatures hot enough to melt many metals. To survive this journey, Starship relies on thousands of individual heat shield tiles covering much of its exterior. Each tile has a specific purpose. Together, they form a protective barrier that shields the stainless steel structure beneath from the extreme heat of re-entry. But building the heat shield is only part of the challenge. Every single tile must remain attached while the vehicle experiences violent vibration, rapid temperature changes, and enormous aerodynamic forces. If even a small section of protection is lost, the exposed structure can overheat within seconds. That is why every flight provides engineers with another opportunity to improve the system. After recovery, the data collected from sensors and cameras helps identify areas that experienced higher temperatures, unexpected airflow, or unusual stress. Those lessons feed directly into the design of the next Starship. The same philosophy applies to every component on the vehicle: engines, flight computers, fuel systems, avionics, control surfaces. Nothing is considered finished. Every launch leads to another round of improvements. Instead of waiting years to design the perfect spacecraft, SpaceX chooses to improve the vehicle continuously. It is a strategy that has allowed the company to move at an extraordinary pace. Of course, Starship is not being developed for a single mission. Its goals extend far beyond low Earth orbit. NASA plans to use a version of Starship as the human landing system for future Artemis missions, carrying astronauts from lunar orbit to the surface of the moon and back. That means the success of Starship matters not only to SpaceX, but also to one of the most ambitious human spaceflight programs of this century. Beyond the moon lies an even greater challenge: Mars. For decades, sending humans to Mars has remained one of humanity's biggest dreams. The distance is enormous. The journey takes months. Every kilogram of cargo matters. Every kilogram of fuel matters. Every engineering decision matters. That is why Starship is being designed as more than just a rocket. It is intended to become a complete transportation system capable of carrying people, supplies, scientific equipment, and eventually entire crews across interplanetary distances. No one can predict exactly how many more test flights will be needed. There will almost certainly be more challenges, more unexpected problems, more redesigns, and perhaps even more spectacular explosions. But history has shown that major advances in aviation and space exploration rarely happen without setbacks. Every generation builds on the lessons learned by the one before it. The same is true for Starship. Each vehicle improves on the last. Each flight brings new knowledge, and each success moves humanity one step closer to becoming a spacefaring civilization. When people look back at this period decades from now, they may not remember every flight number or every prototype. What they will remember is that this was the era when reusable, super heavy rockets became reality. the era when launching massive spacecraft began to resemble an industrial process instead of a once-in-a-generation event. And perhaps the era when humanity truly began preparing to become a multi-planet species. Whether Flight 13 is remembered as a historic breakthrough or simply another important step along the way, one thing is certain. The Starship program continues to push the boundaries of what is possible. And for millions of people around the world, the next launch cannot come soon enough. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications to stay up to date with the latest news from SpaceX, Starship, and the future of space exploration. Let us know in the comments. Do you think Starship will reach Mars before the end of this decade? Thanks again for watching, and we'll see you in the next video.